Welcome to APDesign Visual Tools. Today we're going to be working on creating a space frame of its most basic kind of structure. To get started, we're going to look at putting down a grid. So go to Vector and grab a grid. Rectangular grid will be fine. And we'll just throw on some sliders for its size in X and Y, and its extent. So this is how large the grid is. So there we go. We may shift these just so we know how it's being built, so we know these numbers are kind of different. The size really probably doesn't really need to change. So there we go. And let's look at what we are getting out of this. We have a series of rectangles. So each cell of the grid is a single rectangle. The structure of the of how the lists are organized are such that the 0 rectangles here, and then it goes, and that list is all combined in those rectangles, and then the second list here is the series right here. So set up in a kind of column structure. And other things that we get, we have a series of points, and we'll go ahead and put a point list on that. This is often a great way of kind of researching if you're having issues of untangling a series of points. You use this point list, and it allows you to look at how it's structured, how it's organized, the points. So this is similarly structured, where we have the 0 point of the rectangle, and again in this kind of column structure. Alright, so what we need to do, let's just draw one in Rhino real quick. Like, imagine I'm just drawing one of these rectangles. Kind of what I'm trying to create is, if this is a cell, I want to create a point that's at the center of the rectangle, and then I'm going to move that point down in space some increment. I'll just put 10 units. And then what I want to do is build a kind of a pyramid from that point to each of these corners. So essentially this would represent the kind of beginning structure of a space frame. So one then can imagine, you know, that being replicated over and over again. It would create a nice little space frame. Alright, so that's the end goal. So to achieve that, I'm going to do a couple of things. I'm going to take the curve set we have here. I'm just going to type in a curve parameter, and so I can just kind of make this go away. And I'll go ahead and make that go away. And let's go ahead and explode that. When you explode a curve, you get two sets of information. You get all of its lines that created it, so each line, all 4 of them, and you get a series of vertices. And these are also what create the rectangle. So if we draw from this point to that point to that point to that point, and then come back to the end, you'll see that these 0 and the 4 are both the same point, and it follows if we look at the next list down. Essentially that closes the rectangle. So let's look at that so we understand it completely. Instead of looking at each one where you can see all these points are getting jumbled on top of one another, let's just use an list item, and we're going to look at just one So I'm going to flatten the list, and the list item is set to 0, so essentially instead of looking at all of these in these kind of all this large list, what I've done is I've flattened that list so it'd be one large list, and I'm just looking at the first one. So I'm going to stick that into here, and we'll see that we have the vertices are again starting at 0 to 1 to 2 to 3 and then back to that original point, but we actually have a fourth point or a fifth point being recognized. Well, what I really now want to do is I want to get rid of that fourth point, or I want to get rid of either the 0 or the 4, because I really want this to be just 4 points. Keep it simple. So to do that, what I'm going to do is I'm going to call an index. When you create each of these, when you have a list of information, this 0, 1, 2, 3, this kind of left panel, this left part of the panel, that's your index number. So if I want to just look at item 0 of this list, again I would just grab an item, list item, I plug it in here, and because the index number is 0, it would just be looking at that one point. If I put a slider on that, I can look at 0, 1, 2, 3, 4, and then after that there's no more. So I can look at, I can kind of basically call out just that one that I want to look at. Alright, well now I'm going to call out, so I'm going to actually get rid of one of these numbers because I have an extra one. I don't want to have 2 of these vertices. So to do that, I'm just going to use the call. I'm going to attach it to the list. I'm going to give it a number value, say 0. I can either use 4 or I can use 0. It is important that you understand that if I use 0, say this grid is a hexagonal grid, then suddenly I would have 7 points, one extra. If I use 0 each time that I get rid of, I'm always going to get rid of the first one, but I'll always have the last one. So this is probably the best method, use 0. So now I have just the 4 items. Great. Now I want to find out where the centroid is. Well, to find out where the centroid is, you actually have to add each of these points together and then divide by the number of points that you have added. So I'm just going to use this mass addition. Mass addition, you can find that under math. And right here under operators, mass addition. I'm going to add them together, and that gives me basically added all the x's, the y's, and the z's together, and then I'm going to divide that result by the number of sides, or number of vertices. Sorry, the number of vertices. So I'm going to use a list length. The list length finds out that number. Even though I know it's 4, it's better for me to use this. If I plug in 4 and then I go to a hexagonal grid, well, that number is not going to be 4 anymore with the hexagonal grid, it's going to be 6. So if I use this, if I change this grid later to hexagonal or triangular or whatever, I'm always going to end up with the right result. This is called relative information. If I put in 4, if I just go in and plug in 4, it'll be right. It'll be right for now, but as soon as something changes, it'll be wrong. And then I have absolute information that's going to screw me up. as opposed to relative information, which is going to keep it strong and working. Alright, so then that should be, now the result is your centroid. That's the centroid of the rectangle. It just can't be, don't change, if I change this, you can see that centroid actually is adjusting. Okay, the centroid isn't necessarily called, not necessarily the center. It is the kind of the average point within that whatever polygon you're using. All right, so we'll move that down. So I want to go in Z, kind of going a little quick now. I want to go a certain number of units. And we'll call that the depth of Spaceframe. Alright, you'll notice that the point went up. I'd rather not do that. I'm going to use a reverse vector. That just, again, reverses the vector to direction, so instead of going up, it's going to go down. Alright, and now I'm going to use a line to connect the centroid, this bottom part, to each of the vertices, which, remember, we want to use the call one. If we use this one, we will get we'll get an extra line, essentially. Alright, so that's that. Looks a little funky. I'll turn it down a little bit. Alright, so it worked for one. Let's go ahead and see if it will start to work for all of the curves. Again, we just isolated one. Okay. Turn off this. Alright, so there you go. There's your beginning of a space frame. Readily adjustable. Even the depth.